Welcome to Unit 4, Lesson 3, the factor theorem. So the factor theorem is a polynomial in x, p of x, has a factor x minus a if and only if p of a equals 0. So what we're doing now is looking at if we have a binomial x minus a and it divides perfectly into our polynomial, then we're left with no remainder at the end. And if that is true, then we can say that that binomial is a factor of that polynomial. So I have an example here with a bunch of different factors. And you might be wondering, like, why did I pick these specific numbers? So we're going to talk about that shortly, but basically we're looking at the constant term in a polynomial and looking at what are the factors that can give us a positive 6. So our possible factors of 6 could be positive or negative 1, positive or negative 2, positive or negative 3, and positive or negative 6. So these are all possibilities to create binomials to see if they are a factor of that polynomial. So I just did an example of each. All I did here was state, okay, if x plus 1 is a binomial factor of this polynomial, then a equals minus 1, and I found p of minus 1. So whenever there's an x, I just plug minus 1 in and solve for it. Now at the end, we get a remainder of 12. So that tells us that x plus 1 is not a factor of the polynomial x cubed minus 7x plus 6. If we move over to x minus 1, you can see I've done the exact same thing. I've just substituted the value, found that a equals 1, and then solve for it. And once you get to the end, you see we have a remainder of 0. That tells us yes, x minus 1 is a factor of the polynomial x cubed minus 7x plus 6. Now, of course, once you know 1, then you can kind of sort it out and see if there's other factors by using some tricks, but you can also continue on with each of the possible factors of 6 and see if they divide evenly into that function. I've done the additional examples here. You can see only these two, x minus 2 and x minus 1, are factors at this time, and you'd have to find the third one, of course. But all the remaining ones, they leave remainders, and therefore they cannot be a factor of that polynomial. So a similar example here, done exactly the same as the ones above. All you're doing is just plugging the values of the factors of 3 in, and 3 of them could potentially be yes, yes, and yes, and this one is not. That's a no. So what we do to do this is look at all the possible factors of the constant term, which is 3 in this problem, 3 in this problem, and positive 6 in this problem up here. When we look at the constant term, we have the possible factors of a polynomial that we can use to solve and figure out what are all the factors of the given equation. So this is the relationship between the factors of a polynomial, and the constant term of the polynomial is stated in the integral zero theorem. The integral zero theorem states that if x minus a is a factor of the polynomial function p of x with integral coefficients, then a is a factor of the constant term p of x. So it's another way for us to find the factors. Just like on the previous page, in this given polynomial function, we have a constant term of negative 8. So we just want to determine what are all the possible factors of 8. What are all the numbers that multiply together to give us 8? So of course it's 1 and 8, 2 and 4. When I'm figuring out factors for a number, I like to start from 1 all the time and kind of work my way in towards the middle, because eventually you're going to run out of possibilities. So for example, if I picked 36 and said to you, what are all the factors of 36? We would say 1 times 36, leave yourself space if it's a big number, 2 times 18, 3 times 12, 4 times 9, 5, no, 6 times 6. So as you work from the outside in, it eliminates a bunch of the numbers that you could possibly divide by, and it makes the process much quicker. So for example, if the constant term in a function was 36, then you would list out all these factors and just start at 1 and work at it methodically until you find a factor that works. Now we have this function 2x cubed minus 5x squared minus 4x plus 3, and I'd like you to factor it fully. So the constant term is 3, and therefore the possible factors of x are positive or negative 1 and positive or negative 3. So what I did first was pick x minus 1 and x plus 1 and just plug those values in to see if either of them worked to give me a starting point. So this one, of course, is not a factor because it's got a remainder here, but this one is. So x plus 1 is a factor. Now that we know that x plus 1 is a factor, we can go ahead and use synthetic division to figure out the other factors. You will list out the original function. Of course, it was 2x cubed minus 5x squared minus 4x plus 3. And from there, you can use that synthetic division to quickly sort out what is the other polynomial that we're working with. So once you've done this, you will come out with x plus 1 times 2x squared minus 7x plus 3. And at that point, you want to look at the function that you're left with. If the power on your highest exponent is bigger than 2, then you want to apply synthetic division again until you get down to this x squared term. Once you're here at this x squared term, we can see whether or not this function has some factors. So you can try and factor it. Of course, the x plus 1 will remain, and then try and factor out that polynomial. So we have 2x minus 1, x minus 3. Of course, it works in this situation. And these are all the factors of our original function, 2x cubed minus 5x squared minus 4x plus 3. So if you multiply these two together in a calculator that does polynomials, then you will see that your end result will bring you back right to where you started. You might be asking yourself, why the heck are we doing this? Why is this important? And the reason why this is important to know how to do on a polynomial function is because these 3 terms tell us our x-intercepts on the graph. So when we're graphing out this cubic function, it's positive. We know that the general shape of it will be increasing in this direction, decreasing in this direction because it's positive at the leading coefficient. And then we're going to have x-intercepts. This will tell us where to change the direction of our graphs. We'll have an x-intercept at -1. We will have an x-intercept at positive 1/2. And we'll also have an intercept at positive 3. And just in general, not a perfect graph. Our graph will kind of look like this. Does that not look like your x cubed function? Okay, so that's how you know you did it right too. So these become very important if you're not sure what the purpose of them is right now. That's it. It tells us where our x-intercepts are on the graph. Now, of course, we don't always only work with polynomials that have just an exponent of 3. Sometimes the exponent can be higher than that. And if that's the situation that you're given, nothing actually changes. You just have to repeat the steps 1 more time or 2 more times. So in this one, you're given x to the 4th minus 5x cubed plus 2x squared plus 20x minus 24. So our possible factors lay in our constant term of 24. And of course, it's 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So just pick one and go with it until you find one that gives you a remainder of 0, and then work from there using synthetic division or the factor theorem to be able to determine what are all the factors of this original polynomial. So applying the synthetic division, once we know x minus 2 is a factor of this polynomial, we can come out with our remaining factor of x cubed minus 3x squared minus 4x plus 12. And we get a cubic function here. Once you have that, you can go back in because what we're trying to do is find all the factors of the polynomial. So we now know that x minus 2 is one of the factors. And we want to solve and figure out what are the other remaining factors that are left over. So we have x minus 2. What are we multiplying it by? So after applying that synthetic division, you will come out with x squared minus x minus 6, and our other two factors are x plus 2, x minus 3, and this one's squared because we did it twice. Now, there's another additional method that you can use. It's factoring by grouping. And in that circumstance, what you're going to do is divide out a common term. You can see here between x cubed and minus 3x squared, they both share an x squared. So you've divided x squared out of both terms. And then on the last two terms here, negative 4x plus 12, you divide out a negative 4 from both terms. And once that's done, you're able to come up with these factors and then produce this down here. So you know that x minus 2 is an original factor, and then solving this polynomial, x squared minus 4 and x minus 3 gives you these resulting factors, x minus 2 and x plus 2, as well as x minus 3. And all of these multiplied together will give you this original function. If you're wondering how did we get to x minus 3 times x squared minus 4, if you treat this side as a whole term and we divided this whole side by x minus 3, then that x minus 3 would come out and all you'd be left with is x squared minus 4 in the second term. So that's how you would solve for that. I personally think method 1 is much simpler. Beyond this, you have some practice questions that you can complete independently for tomorrow.